to that folder in the next time. You should know the commands, what command you will type to open the folder. So like that, each and every task you have to do through the commands. Okay, where in command line operating system. Linux is a command line operating system. In your practical, you're going to study about that. Okay. Okay. Students, till now in the operating system. Students, am I audible? Any disturbance? Am I audible?
Yes,
Okay.
you're audible.
Okay. 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 Wait a second. I have to enable one option to make me as an organizer. I'll do that quickly. Did it. Okay. Students, in the practical, I did not say start to teach anything. Okay. In operating system, in the practical, you're going to study about Linux operating system. Okay. Like Windows, Android, Linux is also one of the operating systems. Okay. We are going to study some basics about that operating system, basic commands in the operating system in that practical. Okay. So what is the operating system practical? Linux. Okay. Why I'm saying basics? Because in TY, third year, you are going to study a subject called Linux administration. Okay. So in that detailing, you will study about the Linux. Here, as you are studying the operating system, you should know any one of the operating system. Of course, you all are using Windows. You all are familiar with Windows. So I no need to say anything about the Windows. Okay. So one command line operating system you should know. That's why as a practical component of operating system, we have kept Linux. But in this Linux, basic commands you will study. And TY in Linux administration, you will study detailing about the Linux, shell programming and all you will study there. Here you will study only commands. Okay, that is going to be your practical of operating system. Okay, that's what I said. Okay. Practical, I'm not going to start now. Okay, today I'm not going to start. I will inform you priorly before starting. Okay. Students in the operating system, last 1 week I did not take the lecture. I had gone for refresher course. I have to attend the course. Okay, 2 years once. So that I attended, I completed. Okay. That's why the last 1 week I couldn't take operating system. I did not take any of the lectures. Okay. In operating system, we started actually 1 or 2 lectures I took. Okay. Just to quick recall, I'll tell you what we studied in operating system. We started understanding what is operating system. Okay. Whether it is a hardware or software, where it will be located. Okay. There are many services the operating system will provide. Okay. It will manage all the resources, all the hardware, and it will create the process, it will delete the process, and then it will call the system. That's called system call. There are many scheduling means in multi-processing operating system. In multi-processing operating system, multi-processing operating system means what? In a Windows, you are opening multiple applications. Okay, you are hearing song and you're typing something in Word. Both are happening simultaneously. Okay, how the input output memory devices will be allocated when you're doing multi-processing like that? More than one number of application you will open and you will use all the applications simultaneously. So some manager should be there to manage everything, all the processes which is getting executed at the time. Okay, for that we have operating system. Okay, students, first you have to understand where the operating system is required, where it is not required. Where the operating system is required, where it is not required. Where it is not required, there is a electronics, but there is no operating system. For example, um beverage. Yes, a beverage vending machine. Now washing machine also, now it is a smart washing machine, because um, that washing machine has to sense more than one number of things at a time. So that is also having some nowadays operating system. But we can say semi-automatic um, uh, this uh, uh, this washing machine is what example for non the device which is having non-electronic device, but does not have operating system. Okay, why in those electronic system operating system is not required? Why in our system, in our processor, computer, and the laptop, there the in a smart mobile, there and all operating system is required? This you have to understand. If you take non-operating system based electronic devices, for example beverage vending machine, as one of you said, washing machine and microwave oven, air conditioner nowadays we can't say, because air conditioner there are many they included they made that as a IoT device now. So normal air conditioner we can say, it's not a smart one, which will not have operating system. Why there is no need of operating system? Because at a time more than one process will not happen. Sequentially it will happen, one after another, one after another. First you will put the cloth, you will start the washing machine, and then you will put the cloth, and then after you put the cloth there will be a sensor, there will be actuator, actually there will be a machine which will rotate the drum of the washing machine to find what is the load, amount of load of the clothes, and then accordingly next it will pump out the water, and that water level sensor will be there inside. After the water level reached to particular level, then it will stop pumping the water. So like this, one after another only the process will happen simultaneously, no two processes. Okay, so there is no need of manager, and there is no need of operating system. Where the operating system is very much required, when the user is doing more than one number of process task at a time, underline simultaneously or at a time. Okay, that that time only you need what? Operating system. Because when you simultaneously, when you call more number of processes and you are working on that, each and every process may need some input device, output device, memory, RAM. So to whom it will allocate, when it is allocating, of course it is a multi-processing system. So simultaneously everything for all the processes, all the requirements should be fulfilled, should be given by the operating system. So what will happen? It has to first um, suppose memory is going to be shared by 4 different processes, okay, in your computer. So operating system should decide which portion of the memory is going to be used by the process 1, which is going to be used by process 2, process 3, process 4. So this is called resource allocation. This is called operating system as a manager, resource manager. It has to manage. And there are more number of processes are asking to execute, to use the processor, CPU. Then the operating system should decide, okay, because we have only one processor, right? So the processor should be given to which process. Okay. Of course, even in multi-processing system also, one process can use a processor at a time. Okay, because there is only one processor. Okay, so operating system should follow some algorithm to allocate what? Allocate the processors to processor to the processes. Processor means CPU, CPU to the processes. Okay. when it is multi-processing system. So all these are managed. Not only this, there are many other things, services provided by the operating system. In your syllabus, first now we are in introduction. We are seeing introduction is actually big introduction for operating system, because you have to study. Just you have to at least to know about what is IO devices, what is processor, how the instruction will be executed, instruction cycle will have what are the steps, what is pipelining in operating system. So all these are basics. Not only this, these are hardware related things. You have to know IO devices. When we are talking about IO devices, what is IO controller, what is IO device driver, it's a software. So all these are very basics. And apart from that, you have to study about process, how the process will be created, what is the I said algorithm. Operating system will follow algorithm to allocate the processor to processes. Okay, what is that algorithm? All these are what? Basics. Okay. Before you understand the services of the operating system, before you understand services of the operating system, what is services of the operating system? Resource allocation, process scheduling, memory management, mm, secondary memory, that means file management. Secondary memory management is nothing but file management. All these are different, so many services, different services which will be provided by operating system. Directly, you can't study the service. You will not understand anything. Before that, you need to understand many basic things. Okay, so it's very, very, very vast, but very, if you really understand, it is very interesting subject. Okay. So we did not start till now what are the services of the operating system. We are in basics. Okay, basics also there are more. Okay. So first we are trying to understand some basics about the hardware. Okay. That's where we were in. One second, I will share the. Okay, this is the diagram I showed. CPU is there, memory is there. Here only one memory they have given, but actually see this operating system will manage RAM, ROM, and hard disk. That means our file system. And these are input output devices. We have a memory device, and for that memory controller, disk controller. And we have input device keyboard, we have keyboard controller, we have output device monitor, we have video controller. So each and every input output device, each and every device will have its own controller. Okay. So in that we discuss about CPU. We discuss about the layers of memory and all. And we compared the speed and storage capacity of the memory, remember. And now we have to know about input output devices. Even we discuss about the hard disk also. Okay. You remember I said a hard disk will not have only one disk. It has layers of disks which are called platers. And we understood what is track, what is sector, what is read write head, how many read write head would be there in each and every disk, what is cylinder, and what is access time, seek time. So all those we understood about the hard disk. Okay. So we discuss about the CPU, we discuss about memory. Students, I actually should not say we discuss about CPU. Some introduction, which is very basic. CPU is also vast processor. Okay. So just if some knowledge we got, which is helpful, which will be helpful to understand the operating system. Okay. So CPU we discussed, processor. Memory we discussed. Memory also only the layers of memory and different names of memory. Which memory is very speeder memory? Why it is very speeder one? If it is speeder, why the capacity is very low? So that and all we discussed. Okay, about the memory. And we discuss about the structure of what hard disk. After that, now we are going to discuss about the Input output devices. Anybody wants to ask anything? Any query? Am I going very fast? No. Okay. Okay. Now we are going to understand I/O devices. Okay. You know I/O devices, input devices, output devices, um, keyboard, mouse, joystick. A pen drive is USB based memory device, memory unit. Okay. And output devices. There are standard input output devices. When I'm saying standard, which all the device will have, all the microprocessor based device will have. So what a standard input output device? Of course, keyboard is a standard input device. Keyboard will be there in all the processors. So it's a standard, underline the word standard input device. Screen display unit. That's a standard output device because even some of the systems now our home PC and all we are not having printer as output device. We have, but however we will have what monitor. So the monitor is what monitor or display device, display unit. That's a standard. Underline that word standard output device. So there are standard output device, standard input device, and apart from that, we can plug in many external input output devices, mouse, printer, plotter, scanner, and all. Okay, all these are what input output devices. Okay, so the CPU and memory are not the only resources. See, when I'm saying resources in operating system, there are two. One, maybe I may point the hardware resources or software resources. Hardware, software, both are called resources. Generally, we will think when we are saying resources, okay, that would be the hardware. No, software also resources. But here we are talking about only hardware resources. Okay. So CPU and memory are not only hardware resources that the operating system should manage. Operating system should manage apart from CPU memory, IO devices also, input output devices also. Shortly, you will write input output devices as I/O devices. That denotes input output devices. Okay. IO devices also interact heavily with the operating system. Interact heavily with communicate with the operating system. Okay. IO devices generally consist of two parts. One is two parts with respect to hardware, I'm saying. Okay. The device itself and the controller. Okay. Physically, if you see a hardware device, it should have two components. One is the device itself. If I'm saying keyboard, the keyboard. You know keyboard. When I'm saying mouse, you know mouse. What? That is a device. The device itself and also controller for that device. That is also hardware. Okay. So IO devices generally consist of two parts, the controller and the device itself. The controller and the device itself. What is controller? Device I no need to because you have seen controller. The controller is a chip or set of chips. Controller maybe a single chip or set of chips that physically controls the device. That will physically control the device. Which means the controller will accept commands from the operating system. For example, if the device is a input device, so it will accept the read command and it will give the through the read command whatever the data required that will be given by the controller. Okay, so you can assume between the CPU memory, between the CPU memory is one side, our input output devices is another side. In between there is a controller. Okay. So CPU will not directly communicate with the input output device through the IO controller, input output controller. It will communicate with the input output device. Okay. So how can you imagine controller? Controller is a small chip, or it may be, suppose the controller is the device is very complex device, then it will have more than one chip. A set of chips could be a controller. Okay. It What is the use of the controller? Controller will accept some commands from the operating system and it will execute it. Okay. For example, it can accept uh, read command and to read the data from the device, and it will carry out the data to the requested processor. Okay. When you take disk controller, we know hard disk is there, okay, in the system. So when we take disk controller, that might accept the command. The command would be, for example, read sector 11,205 or 206. This could be a command. Read sector number 11,206 from disk 2. This could, but the command will not there in this format. Okay, but that will have the information. If your controller, that means your device is a disk controller, device is a controller is a disk controller, then the disk controller may get the request from the processor uh, such that to read the sector number so and so from disk so and so. So what the controller, upon receiving this read command from the processor, what the controller should do? Controller then it has to control this linear number, 11,206, that linear number to the proper cylinder number and sector number, and which read write head will be used. Uh, so then only what it has to the controller can exactly find where actually the sector number 11,206 in the disk. Okay, because there are more number of disks. Which disk number? Disk 1, disk 2, disk 3, disk 4, which disk number? And inside the disk of course, okay, I found this operating system found it's a disk number 2. Now, okay, in the disk number 2, where actually this disk, the track number, sorry, the sector number 11,266 will be. For that, first you have to find the controller should find the track number, and then it has to find the sector number. All these will be done by the controller. For example, we have taken disk controller. Like this, different devices will have different controller. It will have its own work. Okay, what it has to do. And here it's little challenging task in this example which I said, finding the sector number 11,206. That's when you're seeing the command is so simple, but the internal work which should be done by the controllers is very complex sometimes. For example, suppose the number of sectors of each track is in different number. Okay, that is the architecture of disk. Assume. Then it is more difficult, more complex. Students, are you following? I said already when I was explaining hard disk. In some of the architecture, every track in a disk, track, you could imagine now. The concentric circles are called track. Every track, inner track or outer track or middle track, whatever it is, all the track will have same number of sectors in some of the architecture. In some structure, inner track will have less number of sectors than the outer track. It is obvious, right? Because the outer track is more space, having more space than inner track, right? So in that architecture, it is very difficult to find the sector number. That means the information given by the processor should be executed by the controller. No, that is little complex. So like this, complexity will increase or decrease. That is completely depending on the input-output device. Okay. So the controller has to then determine the cylinder number, because cylinder number is not there in the query which is sent by the processor. It will send only read or write instruction, and the if it is read command, which instruction should be read. If it is write command, where it should be written, in which address it should be written. So only these information will be given by the processor. Rest all should be done by the operating system and also microcontroller. Sorry, not microcontroller, controller of the device. Okay. So it has to find the cylinder number, and then it has to wait until the proper sector is getting rotated and reached, and then it has to go to the particular data point, and then it has to read the data. So when we are saying it is easy, but internally it is little complex, and the complexity increases and decreases depending on the input or output, type of input or output device. If it is hard disk, it is very complex. Okay. Each type of controller, students, we are discussing about the IO devices. In the IO devices, why we have to discuss about controller? Because IO device is not a single device, single peripheral. It has two parts in it. One is the actual peripheral itself, the IO device itself. The another one is a controller. That's why we are studying about the controller here. Okay, IO controller. Each type of controller is different. Remember, keyboard controller, if you look at the picture, keyboard controller is different from video controller. Video controller is different from hard disk controller. Okay. Why it is different? Because the functions are different completely. Okay. So each type of controller is different. Different software is needed to control each controller. Different software is needed to control each controller. Okay. So every controller will have its own software. Okay. Students, please understand. Every input or output device will have input device will have its own controller. Each and every controller will have its own software. Each and every controller will have its own software. Okay. That software is called a device driver. Device driver. Okay. Any new software when you install, any new hardware when you embed, definitely its respective driver should be loaded. Okay. So when you buy the scanner that manufacturer will give a small disk. The disk will have controller. You have to load it. Okay. Then when you load, it will automatically will go inside the operating system. The driver will be a part of the operating system is a software. Okay. So this device driver software will automatically get linked with the operating system. Okay. So where the device driver will be? Device driver will be the kernel of the operating system. Kernel. Kernel mode. Processor will work in kernel mode and user mode. We discussed. Students, could you follow? Can you understand? Okay. So each type of controller is different. Okay. As the controller is different, each and every controller should have its own device driver, which is nothing but a software. What is device driver? The software that talks to the controller. Talks to the controller means what? It gives a command and accepting the responses from the controller. It receives the commands and it responds for the command. Okay, so that is called a device driver. So device driver is close friend with what? Controller. Controller is very close friend to devices, input output devices. But device and controllers are hardware. Device driver is a software. So device driver should be loaded within the operating system. Operating system is also software, no? So device driver would be the part of the operating system. But the device driver, whenever you use the device driver will be executed. Its respective device driver will be executed. So when the device driver is getting executed, the processor should be there in the kernel mode, because this device driver is a software which is directly going to handle the hardware. Okay. So it will have sensitive execution, instruction execution. So it should be there in the kernel mode. Okay. Each controller manufacturer, for example, I am manufacturing a keyboard controller. Okay, so each controller manufacturer has to supply a device driver for each operating system the controller supports. Are you getting this? You may ask, ma'am, suppose I bought one device driver. Okay, that device driver is for scanner. It's a scanner device driver. Okay, for example, Epson, the scanner device driver. A particular model I'm buying, the scanner I'm buying, I'm getting a device driver. Okay. I am using that driver for my Windows operating system. Okay. Assume in my another system or my friend or somebody else, he is also using the same driver, exactly same scanner. So the same driver, we can't say same driver, same scanner. He also bought same scanner, but his operating system is a Unix operating system, not Windows. Now he will also have the same device driver? No. Though the scanner is same, exactly same, the device driver will differ operating system to operating system. Remember. So when I assume I am one of the manufacturer of scanner electronics device. In that, one of the my manufacturing product is scanner. Okay, so when I manufacture the scanner, I will create a separate driver for Windows operating system, Linux operating system, Unix operating system. If it is Android operating system. For each and every operating system, I will create a different driver for the same scanner. Understand? Okay. And it is not only for Windows, there is a common driver. Remember, that is also there. The scanner will come with the drivers for Windows 2000 separate, Windows XP separate, Windows Vista separate, Linux separate. Remember, it's not all the Windows operating system, there is a single device driver. For each and every version, release of the operating system, the manufacturer should what? Give a different device driver. So software will differ. Software will differ operating system to operating system. That means each and every version of the operating system, I'm saying. Okay. The device driver which you are using for a particular scanner for Windows 2000 cannot be used for Windows 10. Okay. So it will differ operating system to operating system. Which one differ? Device driver. Okay. And I said one sentence, the device driver will be loaded inside the operating system. So for that, you will not do anything. You just insert the disk and you will run the disk. Automatically, it will happen. It will be linked. Not linked. There are three ways. There are three ways the driver can be put inside the kernel of the operating system. There are three ways. And you may ask, ma'am, always the driver will be loaded in the kernel of the operating system. Udhar bhi thoda what? There are exceptions. Some of the students, there are many important points you have to note down. If you listen and then tomorrow you will forget. So how easily you will understand in that way, you just write and keep. Okay. What is device controller? What is device driver? And every device driver controller play separate device driver is needed or not, how the device driver will differ operating system to operating system, it will differ. When I'm saying this, you may ask, ma'am, then Windows 2000 is there, Windows 10 is there, Windows 11 is there, for what all these Windows there is a single device driver for a scanner? No, there also there is a different device driver for different version of operating system. Okay. And apart from this, as I said, generic pointer. Generally the device driver is hardware or software? Students, is device driver hardware or software?
Software.
Yes, it's a software. Okay. So when you bought a new scanner, you physically however through the wire cable, or you attached the scanner, and you have to run the that scanner ka software, which is device driver given by the manufacturer, given by the vendor from whom you bought. Okay, you will run it. Now this, I said, this device driver, no, that will be attached with that will go inside the operating system, that will be a part of the operating system. So where exactly it will be? Usually, generally, mostly it will be inside the kernel part of the operating system. See, operating system ne kernel code will be there. It is completely software, no, operating system. There are some code which are user accessible code in operating system. Some code are kernel code. Okay. So in that, as a part of the kernel code, the driver will go and will be added. Till 1:30 I have. Why you are asking this?
20:32 ஆயிடுச்சுல.
Okay. So device driver will be a part of the kernel of the operating system usually, but there are exceptions. Sometimes no, some of the operating system, the device driver will not be loaded inside the kernel. It will be loaded outside the kernel also. But anyway, it is going to be a part of the operating system device driver. Okay. Okay. Now, when I'm saying this device driver will be added with the operating system, you may ask how. For that, there are three ways the device driver will be added with the operating system. Okay. There are three ways the device driver software, no, that will be added with the operating system. Okay. There are three ways the driver can be put inside the kernel. Here we assume the operating system is the device driver is going to be added inside the kernel only, kernel of the operating system only. Okay, we assume that. Okay. The first way is we can relink the kernel with a new driver. Suppose you are loading a new driver. Okay. When you will load the new driver, when you attach a new hardware. Okay. So when you run that new driver, what will happen? It will be automatically linked with the kernel of the operating system. That we can't say link, we should say relink. It will be relink with the kernel of the operating system. Why relink? see, when you add one new hardware and when you run its device driver, it will the link will be link of that. It will not add the entire code of the device driver inside the operating system. Only the link will be loaded in the kernel of the operating system. Okay. So when you buy another device and when you run the device driver of that new device, again one more link will be added in the kernel of the operating system. So this is one way. And after you added, of course, you have to reboot the system. Underline, you have to reboot the system. Then only what you added, no new device driver you added in the kernel, that will be start to work. Okay. Students, in the first way, how the device driver code will be attached with the kernel of the operating system? You will run the device driver code first time. After, see, before you run the device driver, you must have attached the particular device with the system. That's the first step. You physically connected the device and then you have to run the device driver. And in that case, if operating system finds it's a new device driver, it will create a link for that device driver within the kernel. Okay. And then after you did this, you have to reboot the system, or you no need to reboot. Automatically it will ask you to reboot the system. You will reboot it. Okay. This is very common in the older Unix version. Okay. This is the way the device driver will be attached with the operating system in older Unix operating systems. Okay. The second way, what will happen when you run the device driver, it will make an entry in an operating system. It will not create a link. It will create a entry in an operating system file, which means whenever the device driver is getting used after that, that entry, that particular entry, only that entry will be executed. Okay. For here also, you have to, the operating system, if it makes the entry for particular device driver, then you have to reboot the system here also. Okay. Students, first method is creating link. Second method is making entry. Creating link, making entry. Okay. This in the making entry, this is a method which will be used in a Windows operating system. Okay. Inside the kernel code, there will be an entry for each and every device driver. Okay, that's the second method. Third method, on the fly, you can attach. For example, you have USB driver, USB port you have. In the USB port, you attach some device, any USB supported device you are attaching. So on the fly, automatically, the device driver will be called. It will not be permanently attached or linked or making entry with the operating system. But on the fly, it will call the device driver whenever you're using. And then it will create it will execute the device driver. That's the third way. Third way is on the fly. On the fly, now you will attach wherever it is required and you will remove. This will happen usually in USB and IEEE 1399 devices. There are devices which are called USB devices. That means, for example, USB mouse, USB printer, okay, USB pen drive. So all these are USB based devices. So these USB based device, when you attach, immediately you can use it. Okay. The on the fly, the device driver will be called and it will be executed when you're using the USB based device. So these are the three ways it will be attached, which will be device driver will be added with the kernel of the operating system. Kernel of the operating system. And we know about the controller device driver, and more about the controller, you should know every controller has a small number of registers, memory. Okay. This already we saw, okay, each and every controller will have its own memory. That is called a controller register. See, within the CPU, there are different set of registers. Don't confuse that with this. Okay. So every controller has a small number of registers. Small number means what? Very less space memory, which is called registers, which are called registers. Okay. Okay, that registers are those are buffer very temporarily you can store the data. For example, 1 byte of data, that means 8 bit you want to retrieve. Okay, your microprocessor is a 8-bit microprocessor. Assume, because nowadays 64 bits microprocessor commonly we are using, but assume it's a 8-bit microprocessor. 8-bit microprocessor may 1 byte by byte only the data will be sent, because 8 bits equal to 1 byte, no? So, but the retrieval of the data will be what? 1 byte by byte only. For example, keyboard may at a time one word you will type or what? No. Character by character you will type, right? So first character when you type, okay, that character will be converted to the binary code, and it will be byte by byte. It will go to what? It will go to the registers inside the controller. And then if suppose register size is 1 byte, 8-bit, then the register will be filled after you stored 8 bits. Then it will go to destination. Okay. It is not like you will load 1 bit, that bit will go to destination. Again, the second bit will go to destination. ऐसे नहीं है. You will temporarily buffer all the 8 bits in one register, which is there inside the controller. And then from the controller register, it will go to wherever it has to go. Okay. So for that we have a small register which is there in the controller. Okay. Okay. Now you know what is IO port. We are saying no port, 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 port. Okay. So that also I want to mention here. See, now these device registers are there, no? Device registers, controller register. Okay. Now this register, each and every register, for example, 4-5 controllers are there. Each and every controller's register will have its own address. So that address only we are calling as ports. So IO port space means what? The collection of all the device registers form this port. Always remember, this is also very important. When we are easily calling port number, why? What is that port number? That port number is specific to a particular application. Okay. So here we are talking about IO port. Okay. So each and every now this device control control registers I said, no, the control register will have address. Okay. So those all the suppose 4-5 controllers you have, then 4-5 different control registers will have. Each and every control register will have its own range of addresses. So all these address space is togetherly called IO port space. IO port space. Which means one thing here you have to observe, the controller register's address will not be repeated. It is unique. Okay. Suppose scanner, now see, look at the diagram. We have hard disk controller. Okay. So hard disk controller will have its own what? Memory register. So inside this, of course, hard disk will have completely memory. Okay. Inside this hard disk controller, there is a small, assume there is a small register. Okay. So inside that register will have address range, for example, 1000H2 1010H. Okay. So now this address will not be repeated in any of the control registers. Okay. It is unique. Togetherly in the entire system, this address is unique than the other addresses. Okay. Then only we can call it as a IO port space, no? So IO port space is nothing but the addresses of the controller registers. Okay. So that is another one you have to know. Okay. What time is it? No, actually, I have to wind up now. No, now at 1:34. Okay. Okay. So we will see how the microprocessor and IO device will communicate. There are three methods it can communicate that we will discuss in the next lecture. But whatever I taught, no, that is there in the book, page number 28. Okay, total number of pages are here as per this PDF 552. In that page number 28 May, you can see whatever I taught. Okay, you just to go through and come for the lecture, next lecture. I will ask questions. Okay. Okay. Anything you want to ask? Uh, Actually, after your class started, 2 weeks later we will start the practical because no, last semester also we started like that only. 1 week got over, no, or 2 week got over. Other practical are started. NSM. Oh, okay. Huh. We will start in this. I should see the timetable, which are the days you have practical. We will start mostly this week or next week, not later than that. Okay, mostly we will start this week, or if not next week. Okay. Students, your strength is what? 130, 119, but only 68 students are there in the meeting. Coming 12th, we are going to conduct the PTM, parents teachers meeting. We officially we did not inform, but we decided and we are working on that. Your attendance, everything will be shown to your parents. Individually, we will meet the parents through online. Okay. You will get the notice tomorrow or day after tomorrow. Okay. Okay. Thank you, students. You all can leave.
Thank you, ma'am.
Students, today I did not ask any question. During next lecture, you have to go through and come whatever I taught. Remember.